A good day I would like to wish to our lecturer, Associate Professor Dr. Hairul. So today our Group 2, Subgroup 5 will present our group project titled Designing a Comprehensive Laboratory Safety Protocol. Our group consists of 5 members, which are me, Mohammad Danial bin Mohammad Zulkiflee, Intan Aleeya binti Zaidi, Mohammad Badrul Hisyam bin Mohammad Mohammad Hamirul bin Mohammad Kamarulzaman, and Zinger, Novek, Anak, Freadison. So this is the contents that we'll be discussing in this presentation, which consists introduction, identifying potential risks, proposed safety measures, regulatory compliance, implementation plans, and also conclusion.
So let's look briefly at the introduction. So laboratory safety is vital for protecting personnel, ensuring research integrity, and safeguarding public health. In clinical laboratories, where biological specimens are routinely handled, the stakes are particularly high. A lapse in safety can lead to hazardous pathogen exposure, sample contamination, or even broader public health risks. Safety protocols like personal protective equipment, regular training, and adhering to standard procedures minimize risks of accidents and laboratory-acquired infections, as highlighted by the WHO. Beyond protection, safety ensures the reliability of diagnostic results and directly impacting patient care and fostering trust among stakeholders. In Malaysia, safety is governed by the Occupational Safety Health Act 1994 and the Biosafety Act 2007. This regulation mandates risk assessment, safety training, and adherence to international standards, ensuring safe handling of infectious agents and genetically modified organisms. By prioritizing safety, clinical laboratories not only protect their teams but also contribute to advancing healthcare and upholding ethical and professional standards.
I will discuss about the potential risks in laboratory settings, focusing on these 3 major hazards, which is sleeping, fire, and also electrical risk. Understanding these hazards is crucial for maintaining a safe working environment. Sleeping is a significant concern due to the wet or cluttered floors, with common causes including spills and uneven surfaces. To mitigate this risk, laboratories can use tools like the pendulum sleep testing device to assess the surface sleepiness and should maintain clear walkways and properly clean spills. Second risk is the fire hazard. Fire hazards are critical as laboratories often contain flammable chemicals and electrical equipment. Preventive measures include keeping workspaces organized, properly storing flammable materials in very certified containers, and provide regular fire safety training for the staff. Electrical hazards pose serious risks as well. Regular inspection of electrical devices are essential to ensure compliance with the National Electrical Code, in short NEC. Ground fault circuit interrupters can help prevent electrocution, but their effectiveness relies on proper maintenance. Next, in clinical laboratories, workers may be exposed to biological agents like bacteria and viruses, including the bloodborne pathogens such as HPV and HIV. Adhering to the specific biosafety levels when handling these biological samples and conducting regular risk assessment are critical in managing these risks or hazards. Next is the Hazard Identification Risk Control HIRARC framework. The Hazard Identification, Risk Assessment, and Risk Control framework is vital for laboratory safety. This process involves identifying hazard, assessing risk using a risk matrix, implementing control measures such as elimination, substitution, engineering controls, administrative controls, and personal protective equipment, which is in short as PPE. In summary, effectively managing risks in laboratory settings is essential for ensuring worker safety. By implementing preventive measures and adhering to the safety protocols, we can create a safer environment for research and also the experimentation. This picture shows the flow of the framework. And then next, to use this matrix, first we need to find the severity column that best describes the outcome of the risk. Then we're going to follow the likelihood row to find the description that best fits the likelihood that the severity will occur. The risk level is given in the box where the row and column meet.
Ladies and gentlemen, I'll be presenting the proposed safety measures designed to ensure the safety and efficiency of our clinical laboratory operation. These measures provide a comprehensive framework for minimizing risk and promoting a culture of safety. To begin with, safety in the laboratory is paramount to safeguard personnel, protect the integrity of the experiment, and ensure the regulatory compliance. Our proposed safety measures are structured around 4 key areas, which are standard operating procedures, personal protective equipment, engineering and administrative controls, and waste management practices. First, let's discuss the SOPs. The SOP ensure consistency and accuracy and reliability in the laboratory practices, which are critical for generating precise and timely test results that directly impact patient care. These guidelines emphasize the prohibition of consuming food and drinks to eliminate contamination risk and destruction. They include detailed instructions for handling hazardous material, waste management, and emergency procedures to safeguard laboratory integrity and personnel safety. Next, we focus on PPE, which act as a vital barrier against potential laboratory hazards. These include wearing lab coats, gloves, and eye protection at all times. Proper attire such as long pants and closed-toe shoes is mandatory to minimize exposure to hazardous materials. Training session will emphasize the correct use and disposal of PPE to prevent accidental secondary contamination. Moving on to engineering and administrative controls, key engineering controls include using biosafety cabinets to handle infectious materials, fume hood for toxic chemicals, and ensuring effective laboratory ventilation. Regular equipment inspection and maintenance such as balancing centrifuges and ensuring ground fault circuit interrupters are functional, reduce equipment-related risks. Administrative controls such as routine staff training and adherence monitoring provide additional layers of safety and ensure that safety protocols remain effective. Now, on to waste management practices. Proper segregation and secure storage of biological and chemical waste are essential to prevent contamination and comply with regulatory standards. On-site treatment processes like neutralizing acids contribute to safer disposal methods. Strict labeling and contaminant guidelines further support safe and environmentally responsible waste management. An integral part of these measures is training and awareness. Comprehensive workshop, targeted awareness campaigns, and visual aids like infographics will reinforce laboratory safety protocols. Ongoing education ensures all staff are up to date with latest safety practices and regulatory requirements, fostering a proactive safety cultures. Finally, monitoring and evaluation are essential to sustaining these measures. Regularly scheduled audits and announced inspections will track compliance and uncover potential areas for improvement. Feedback mechanisms such as anonymous surveys and staff discussions ensure that safety protocols are practical and effective. Metrics like compliance rates, training participation, and incident reports will provide continuous refinement of safety standards. In conclusion, ladies and gentlemen, to propose safety measures from robust SOPs and PPE requirements to comprehensive training and waste management practices aim to create a secure and efficient laboratory environment. These measures ensure a compliance with regulations, protect laboratory personnel, and uphold the integrity of scientific work.
So, regulatory compliance refers to the process by which individual, organization, or entities adhere to and fulfill the requirements set forth by relevant laws, regulation, and industry standards. The importance of regulatory compliance includes better understanding of the implication for risk management processes and also to ensure safety, quality, and ethical practices, and to prevent legal penalties and maintain reputation. So, the regulatory bodies in Malaysia includes the Occupational Safety and Act 1994 and regulation. Next is Factories and Machinery Act 1967. Next is Pathology Laboratory Act 2007 and also the Biosafety Act 2007. So one of the main regulatory bodies in Malaysia is OSHA 1997. The key provisions highlighted the general duties of employer and employees to maintain safe working environment, and the need to report serious incident or occupational illness to the Department of Occupational Safety and Health (DOSH). And then this law also emphasizes on prohibiting assigning workers to dangerous tasks unless there is a proper measures in place. The compliance requirements include the hazard identification, the risk assessment, and the risk control (HIRARC). And they also need to do training and awareness regularly so that the employer and the employees can keep alert on their surrounding. And an audit and inspection also must be done regularly. The non-compliance can be charged up to 50,000 ringgit or 2 years imprisonment. Next is the Biosafety Act 2007. This law mostly highlighted the regulation in handling GMOs. So the key provisions includes the focus on contained use, intentional release, and the importation of the genetic modified organism. And they also need to obtain the NBB approval before carrying out any activity that involves GMO. And then the employers and the employees must conduct a comprehensive risk assessment before handling the GMO. Next, products containing GMOs must be clearly labeled to avoid any intentional release, and regular monitoring by NBB appointed inspectors must be done. The compliance requirements is to submit detailed risk assessment for approval before handling GMO. And then they also need to follow the SOP for the safe handling, transport, storage, and disposal of GMO. The company also need to maintain the records of all activities that involve GMO. For non-compliant, the penalties are fine up to 500,000 or 5-year imprisonment. They also can lead to the termination of their approval. Apart from the two main regulatory bodies in Malaysia, there are other regulatory bodies that are significant in lab management. First is the Environmental Quality Act 1974. This law highlighted the environments in carrying out their works. For example, they emphasize in preventing pollution of environment, and they also establish guidelines and regulation for managing activities that can impact air, water, and land quality. The compliance requirements include to mitigate adverse environmental effects based on EIA findings, and then they also need to follow proper waste segregation, storage, and labeling. And then they also need to conduct regular monitoring for waste discharge. The penalties for non-compliance is fine up to 5,000 or 5 years in prison or both. And last but not least is the Employees Social Security Act 1969. This law highlighted the social security benefit for employees in Malaysia by creating Social Security Organization (SOCSO). The compliance requirements is the employees must register within SOCSO within 30 days of hiring. And then the records of employees' wage, contribution, and employment details must be kept. And then the filing claims for benefit under SOCSO scheme must be told to the employers. The penalties are paying fine up to 10,000 or 2 years prison or above.
Next, we move to the improvement plans for non-compliance. Non-compliance with safety protocols in clinical laboratories poses serious risks. To address this, we propose improvement measures to foster a culture of safety, enhance adherence, and equip personnel with essential resources. First, comprehensive training programs and workshops are key. Specialized training has shown that to increase compliance rates from 62 to over 90%, incentive systems further boost adherence, with one program achieving a 27% improvement. Awareness campaign using posters, infographics, and videos are simply protocols, and reinforcement key messages, keeping safety top of mind. A tiered corrective action policy ensures accountability through verbal warnings, written notice, and suspension for severe cases, while an anonymous reporting system encourages transparency and proactive behavior. Finally, providing accessible resources like PPE, first aid kits, and spill kits supports compliance. By balancing availability with accountability, we can maintain a high safety standard. And therefore, we have outlined a 3-month timeline to implement the proposed safety improvements, ensuring a structured and effective rollout. In week 1, we'll begin with a risk assessment to identify hazards and evaluate existing measures. Week 2 focuses on drafting safety protocols based on these findings. By week 3, workshops will be conducted to train personnel on the new protocols, followed by feedback collection on the week 4. Week 5 and 6 will involve revising and finalizing the protocols. In week 7, the finalized protocols will be launched alongside awareness campaign. Weeks 8 through 10 mark the first monitoring phase to assess adherence and address nearly non-compliance. In week 11, a midpoint evaluate audit will review the protocol's effectiveness. Finally, in week 12, we'll revise and update the protocols based on the audit findings. As monitoring and evaluation are essential to ensure the effectiveness of safety protocols in laboratories, our plan includes 4 key components. First, audit cycle. Regular audits conducted quarterly or biannually will assess compliance with safety protocols, covering areas like PPE usage, chemical handling, and emergency procedures. Unannounced audit will provide real-time insights, and detailed reports will highlight strength, weaknesses, and corrective actions. Second, feedback mechanism. Quarterly meetings and anonymous surveys will gather input from laboratory staff about safety measures, challenges, and potential improvement. A suggestion box, either physical or digital, will encourage continuous contributions. Third, incident reporting and tracking. A centralized system will log all safety-related incidents, including near misses. This data will be analyzed regularly to identify recurring issues and high-risk behavior, ensuring corrective actions are promptly implemented and documented. Finally, performance metrics. Measurable indicators such as compliance rates, incident rates, training participant, and audit findings will monitor progress and effectiveness over time, aiming for continuous improvements. This comprehensive plan ensures accountability, collaboration, and sustained focus on safety in the laboratory environment.
To sum it up all in a conclusion, a comprehensive laboratory safety protocols ensures the well-being of personnel, protects the environment, and upholds scientific integrity. Key measures include engineering controls, administrative controls, and personal protective equipment and waste management. Engineering controls such as fume hoods, biosafety cabinets, and ventilation systems minimize exposure to hazardous substance. Administrative controls focus on systematic safety management, including staff training, standard operating procedures, and emergency response protocols to ensure consistent and safe practices. PPE serves as the last line of defense, with gloves, lab coats, and face shields protecting against chemical splashes and infectious agents. Proper training in PPE use and disposal is essential to reduce contamination risk. Effective waste management prevents environmental harm and ensures compliance. Clear labeling, secure containment, and proper segregation of biological and chemical waste are vital. Safety is a dynamic process requiring regular updates to protocols, training, and risk assessments. It leadership commitment and staff involvement foster a culture of safety, while digital tools and collaboration with regulatory agency ensure adherence to evolving standards. By prioritizing safety, laboratories protect personnel, enhance scientific credibility, and contribute to healthcare advancement.